Good afternoon, everyone.
Good afternoon, sir.
Okay. How are you all? Fine. Very good. So listen, today one topic we'll discuss, that is vertical circular motion. Okay. So one particle is moving in a vertical circle. We'll try to analyze the motion. We'll try to find what is tension, what is velocities. Like that, so many things we'll try to analyze. So you come the topic, right? New topic. Vertical circular motion. Right? Vertical circular motion. So write down here. Vertical circular motion. Right. Vertical circular motion. Here what is happening? Suppose one string I am having here, one string is there. Okay. The string is attached to a mass. Suppose this is called bob. This bob is moving in a circular path. The bob is moving what in a circular path. Its radius is r or length of the string is l. Okay, so it is moving in a circular path here. So do a circle here. On circular path it is moving. Now all of you listen here. Here points I am taking some points. Here 4 points I am taking. This is I am writing as A point, the bottom point. Here B, here C, here D. Okay, this one I am telling is a bottom point. Now this particle is moving in a circular motion. Now you say, if I give certain velocity to the particle, then only this particle can move in a circular motion. Okay. This particle automatically cannot move in a vertical circle. You need to provide certain velocity here. And that velocity should be sufficient to make it circular motion. Well, let's see one velocity here. What is the velocity? VA. Give one velocity VA, which is given at the bottom point. This velocity VA in horizontal direction it is given here. Now due to this it can move in a vertical circular motion. So VA give at bottom point velocity. When this particle reaching at C, I'll give one velocity VC. It reaching at B now velocity VB, like that I can give. So you know, if a particle moves in a circular motion, definitely one force is required for motion. That force is called what basically? Centripetal force. Now this is your string here. This is a string. So in the string there will be tension T. String tension will be what? T. The tension T will provide necessary centripetal force to move this particle in a circular motion. So right here, tension in the string provides necessary centripetal force for circular motion. So write down tension in the string provides necessary centripetal force to move the bob in a circular path. So this is the bob actually mass. So it can move in a vertical circle because of the tension. Tension will provide necessary force. Now next listen here. So first I'll understand here. There are 3 points I took. One is bottom point, and sidewise 2 points, and here 1 point is their top point. Okay, so right here, this is a top point. C the top point, this is the bottom point, A is the bottom point. Okay, now we'll try to analyze the motion. We'll use Newton's second law to analyze this, and we'll try to find what is the velocity, what is the tension at each and every point. Okay, so remember this opposite to the bottom point is basically top point is there. Top point is there. So it is a vertical circle. It is a vertical circle. Now first number 1, remember here. Okay, at bottom point. At the bottom point, if I'll analyze motion, bottom point. So what I can, that means at A point, you can check your object is like this. Okay, upward, vertically upward, one force is acting, that is basically tension. And if this mass, bob mass is M, then downward what will act? Mg. Downward what will act? Mg. And you know, if your object is moving in a circular path, then it will be accelerating towards the center. It will be accelerating towards center. With how much acceleration? SC acceleration. What is SC? Now that is VA square by R. Let me take R is the radius of the circle or radius of the path, circular path. Now SC is this much. Now if you apply here Newton's second law, applying Newton's second law. So what I'll get here, you tell? Acceleration upward direction, tension upward direction. So what Newton's second law I'll write here? Now you know F net equal to what? F net equal to mass times acceleration. What is the net force here? T minus mg, because acceleration upward direction, so T minus mg or TA I'll write here because tension at A. Okay, if I'm analyzing a point A, TA minus mg equal to mass times acceleration. Okay, acceleration nothing but you directly write it is, what is the acceleration here? V square by R. Directly write here it is VA square by R. VA square by R. Direct write acceleration VA square by R. Okay. Now this is one equation you are getting here. At bottom point, what will be equation of motion? TA minus mg equal to m VA square by R. Now similarly you can analyze for top point. So at top point if you will see, at top point, that means at C point, at point C, what analysis you can do? Your mass is there here, and where two forces are acting downward direction. Okay, when a particle at top point, two forces will act downward direction. What is that? One is tension in the string and another is mg. Tension and mg both will act. Okay, and that will provide basically necessary centripetal force. So let me write here both the forces, which is basically one is tension, another is mg. Both the forces acting in the same direction. So here I can write T plus mg equal to, and acceleration is towards down, so m into vc square by r. Why vc square I wrote? Now because at this point its acceleration is nothing but I am taking, it is vc square by r. Okay, vc square by r. Write that one. Acceleration is a, which is nothing but vc square by r at this point. So here one point you are getting here, and this tension I can give as a Tc. Tension given at Tc. Why I am writing Tc here? Now because at C point I am analyzing, so tension at this C point is basically Tc. So Tc and mg both are downward direction, and that is providing necessary centripetal force to move in the circular motion. Okay, so this is the idea you are getting from the picture. One is top point, one is bottom point analysis. So C is basically top point and A is basically bottom point. Okay, so first bottom point, tension is providing necessary centripetal force. So tension and gravity also there, gravity here. So both you are checking there. So net force is coming TA minus mg. that is mva square by r. And when particle is here, on this particle, two forces are acting. The particle is here, two forces are acting, one is T, another is mg. So that one is TCmg, and it is moving with a velocity Vc here. So that one I have given Vc square. Okay. So this one you will just try to understand. Now listen here, condition to complete one vertical circle. Your tension at a top point should be greater than equal to 0. This condition remember. For minimum condition, Tc should be equal to 0. Minimum condition Tc should be equal to what? 0. And for minimum velocity required at top point, what is the minimum velocity at top point you need? To complete one vertical circle, at top point, what is the minimum velocity required? To find that one, this Tc minimum value I have to substitute. Okay, minimum value of Tc, how much that one? That is equal to 0. Now 0 plus mg equal to mvc square by r. mvc square by r. Now here mm cancels, I am getting a word Vc. Vc square equal to gr or Vc equal to root under gr. Clear? Now this is the minimum velocity at top point to complete one vertical circle. Now what is the minimum velocity required at bottom point? That one, by considering this only you can calculate that. So top point minimum velocity how much required? Root under gr. Don't forget, direct question sometimes. Now minimum velocity required at bottom point, applying conservation of energy you can do that. Applying conservation of energy. This is the initial case, this is the final case. This is the initial case, this is the final case. Now initial energy equal to final energy. Can equate. According to conservation energy, total initial energy equal to total final energy. Now this is the initial point, this is the final point. You have to check what is the initial energy at initial point, what is the total energy at the final point. Now initial energy consisting of potential and kinetic, both kinetic and potential. So kinetic initial plus potential initial, I for initial, Ki plus Ui, it is written like this. Similarly, E final is K final plus U final, F for final, kinetic final plus potential. E the total energy always kinetic energy plus potential energy. Now what is kinetic energy? Half mVa square, potential energy 0, your final kinetic is half mVc square, final potential is mg into 2r. Why 2r? Now when you are going up this much distance, is but top point. At top point how much height it is? 2r. And is gravitational potential energy how much? mg into h, mg into 2r. Okay, if you are certain height, from here if you are going certain height h, at this point, what is your potential? mgh. If you are going certain height above the earth surface, so gravitational potential is this much. Now what I am doing, gravitational potential I am writing here mg 2r. So this mg into 2r. Now you can cancel m and m both side. Now what is happening here? Only half va square equal to half vc square plus 2gr. Now 2 multiply everywhere and vc value also substitute. So va square you are getting gr plus 4gr. Now what happened here? Now va square equal to root of 5gr, then va equal to root under 5gr. Yes or no? So va square equal to 5gr coming, then va equal to root under 5gr. That means what came here? Now here va equal to root under 5gr. Va equal to how much you got? Root under 5gr. That is the minimum velocity required. Minimum velocity required at bottom point. To complete what? One vertical circle. To complete one vertical circle. Okay. That means for circular motion to complete vertical circle, what the condition coming on A? Now A condition is coming. A should be what? The velocity of A should be greater than equal to root under 5gr. So to complete a vertical circle, condition at A, this much the condition should come. Equal means minimum condition, greater means more than that also give, no, it will go. But less than that you can give, no, it will not go. So this is to complete circle, vertical circle. This is the condition to complete vertical circle. Vertical circle. So this is what you understood from this. Okay. To complete vertical circle, how much minimum velocity you require. Okay. At a top point also, at bottom point also. At top point, at bottom point. Top point you need root 2 GR, root GR, root under GR. The bottom point what you need? Root under 5 GR. Root under 5 GR. This idea is clear? No doubt? Okay. So this one you remember, to complete vertical circle, this is the condition. V equal to what? Root under 5 GR. Okay. Thank you all of you. If you like, subscribe Vidyalakshmi NEET Academy YouTube channel. All the very best.